warahmatullahi wabarakatuh. Selamat siang semua bagi para peserta guest lecture AMPP SCITS tahun 2021-2022 yang ketiga kali ini. Saya ucapkan selamat datang. Oke, saya kira sudah cukup banyak pesertanya. Saya akan memulai acara kali ini, guest lecture kali ini. Saya buka. Assalamualaikum warahmatullahi wabarakatuh. Selamat siang untuk kita semua. Salam sejahtera untuk kita semua. Yang pertama-tama saya bersyukur kepada Tuhan Yang Maha Esa, yang mana pada hari ini kita semua masih diberikan kenikmatan serta karunia-Nya oleh Tuhan Yang Maha Esa. Kita bisa berkumpul bersama dalam menetapi atau menjalani acara pada guest lecture kali ini yang bertema yaitu Development of Material Selection in Corrosion Engineering yang diselenggarakan oleh AMPP SCITS, dan juga yang mana acara kali ini adalah acara pemaparan atau seminar dari para expert di bidang korosi, yang mana dalam tema kali ini kita mengambil tema yaitu Development of Material Selection in Corrosion Engineering, yang sebelumnya telah juga dilaksanakan beberapa guest lecture, yang pertama dan yang kedua, dan sekarang ini adalah guest lecture kita yang ketiga. Dan saya ucapkan syukur dan banyak terima kasih dan juga kepada Bapak Pembina AMPP SCITS, yaitu Bapak Dr. Agung Kurniawan STMN, yang terhormat Bapak Agung Dr. Kurniawan STMN, yang telah menyempatkan hadir pada kali ini, juga kepada Chairman of AMPP SCITS, yaitu Mas David Krisman, kemudian juga terhormat kepada Ketua Panitia atau Ketua Departemen Professionalism, Head of Department of Professionalism, yaitu Mas Muhammad Ardito Pramudia. Dan juga tidak lupa saya ucapkan terima kasih kepada para panitia yang telah menyiapkan acara kali ini dengan cukup baik, serta juga kepada para peserta semua dalam acara guest lecture kali ini yang telah mau hadir, menyempatkan hadir dalam acara guest lecture kali ini. Oke, sebelum kita memulai acara ini, kita memulai yang baik dengan yang baik pula, yaitu marilah kita berdoa menurut kepercayaan masing-masing. Baik, berdoa, saya persilahkan. Amin. Sudah cukup kata untuk berdoa. Baik, selanjutnya, tidak kenal maka tidak sayang, maka izinkan perkenalkan diri saya. Saya Iqbal Abdi Manggala Putra, selaku moderator pada acara kali ini, yang akan memimpin acara guest lecture kali ini. Oke, selanjutnya izinkan saya untuk membacakan susunan acara atau tata tertib pada guest lecture kali ini. Yaitu yang pertama nanti adalah dalam acara kali ini yaitu ada pembukaan dari moderator selama kurang lebih 5 menit. Kemudian ada selanjutnya itu sesi sambutan dari Advisor Faculty of AMPP SCITS, yaitu Bapak Dr. Agung Kurniawan STMN. Kemudian selanjutnya ada sesi sambutan juga dari Head of Department Professionalism, yaitu Mas Muhammad Ardito Pramudia. Setelah sambutan, nanti ada sesi pretest bagi para peserta atau partisipan yang mengikuti pada acara kali ini. Kemudian setelah acara pretest, yaitu kita akan berlangsung di acara utamanya, yaitu sesi pemaparan materi presentation of Mr. Kang mengenai development material selection in corrosion engineering. Nanti setelah dari acara sesi pemaparan materi ada sesi Q&A, sesi sharing bersama, tanya jawab antara peserta dengan speaker. Kemudian selanjutnya ada acara penyerahan penyerahan sertifikat secara simbolis dari Head of Department of Professionalism kepada speaker kita, yaitu Mr. Kang Kim Ang, dan juga diikuti dengan dokumentasi taking a picture with participant bersama para speaker. Dan di akhir acara ada penutupan dan juga ada post test untuk para peserta. Oke, seperti itu. Selanjutnya untuk tata tertib, saya membacakan sedikit tata tertib untuk dalam acara Gister kali ini, yaitu para peserta dimohon mengaktifkan kamera dan menggunakan virtual background yang telah disediakan. Jadi bagi para peserta yang tidak berhalangan, dianjurkan untuk menggunakan virtual background yang telah disediakan. Kemudian, para peserta yang ingin bertanya dapat mengajukan pertanyaan dalam sesi Q&A dengan menggunakan fitur raise hand atau menggunakan fitur chat dalam Zoom meeting kali ini. Dan bisa berbicara nanti setelah dipersilakan oleh moderator. Kemudian, peserta wajib mematikan mic selama pemaparan materi berlangsung. Dan terakhir, diharapkan para peserta atau partisipan guest lecture kali ini mengisi link presensi, pretest, post-test, dan link feedback untuk mendapatkan sertifikat dalam acara seminar atau guest lecture kali ini. Oke, cukup sekian dari pemaparan senat acara dan tata tertib dalam kali ini. Selanjutnya, kita beranjak ke acara selanjutnya atau agenda selanjutnya, yaitu sambutan dari Bapak Pembina atau Advisor AMPP SCITS tahun 2021-2022, yaitu Bapak Dr. Agung Kurniawan STMN. Pada Bapak Agung Kurniawan, waktu dan tempat kami persilahkan.
Baik, terima kasih Mas Iqbal Abdi atas waktunya. Assalamualaikum warahmatullahi wabarakatuh. Selamat siang semuanya. Yang saya hormati Bapak Kim Kang yang pada siang hari ini telah berkenan ya, untuk bersedia hadir di tengah-tengah kita sebagai pembicara yang nanti akan sharing pengalaman beliau terkait dengan korupsi yang teman-teman dari AMPP Student Chapter ITS ya, segenap pengurus dan juga panitia dan seluruh peserta dari webinar kali ini. Sebelumnya marilah kita panjatkan bersyukur kepada Allah Subhanahu wa taala pada siang hari ini kita bisa berkumpul ya secara online untuk sama-sama belajar dari expert yang kalau saya lihat di website di internet ini Mr. Kim ini luar biasa pengalaman di bidang korupsi ya. Jadi ini kesempatan yang luar biasa kita bisa belajar bersama di sini nantinya. Bapak, saudara-saudara sekalian, bahwa korupsi ini adalah sebuah ilmu yang tidak ada habisnya. Ya, ilmu yang selama kita masih menggunakan material, terutama logam, ya, metal, maka ilmu di bidang korupsi ini tidak akan habisnya. Jadi ini ilmu lama, ilmu tua, namun terus berkembang di sisi faktor yang bisa berpengaruh pada korupsi ini, baik itu pengembangan materialnya, baik itu bagaimana sistem kontrolnya, lingkungan, dan juga bagaimana sistem proteksi. Nah ini terus berkembang, ya, walaupun ini ilmu lama. Jadi ini bagaimana sebuah material akan kita gunakan, terus dia akan berusaha untuk kembali. Dia punya kecenderungan, punya tendensi untuk kembali ke lingkungan. Nah, ini yang akan kita jaga, kita perkuat, kita akan tahan, kita kontrol performanya sehingga di situ kita bisa memanfaatkan ini material ini dalam jangka waktu yang lama. Dan ini saya lihat ini nanti akan sangat menarik ya dari Mr. Kim untuk kita belajar bersama, kita dengarkan bersama, dan ini saya yakin ini akan bermanfaat bagi saudara-saudara sekalian di kemudian hari. Jadi seperti itu, sekali lagi saya ucapkan terima kasih kepada Mr. Kim atas waktu dan juga kesediaannya untuk sharing sharing ilmunya nanti di event ini. Demikian dari saya. Terima kasih Mas Iqbal. Sukses semua. Sekali lagi terima kasih juga kepada panitia yang telah mengorganize acara ini. Demikian. Assalamualaikum warahmatullahi wabarakatuh. Selamat siang semuanya.
Waalaikumsalam. Selamat siang Pak Agung. Baik.
Mute Mas Iqbal.
Iya Pak.
Ya.
Oh iya, baik.
Ke-mute lagi.
Oh iya. Oke, maaf. Oke, selanjutnya kita akan berlanjut ke agenda yang selanjutnya, yaitu sambutan dari Head of Department of Professionalism, yaitu Mas Muhammad Ardhito Pramudia. Oke. Bagi Mas Muhammad Ardhito, waktu dan tempat saya persilahkan. Monggo Mas.
Thank you, Mas Iqbal. Hello. Because of our material is from English, so I will speak in English. Thank you for our participant and Mr. Kim and Mr. Agung and all of the participants to coming for our guest lecture. I will hope that our guest lecture give benefit for us and gain knowledge for us about corrosion. Thank you. Assalamualaikum warahmatullahi wabarakatuh.
Oke, thank you. Terima kasih Mas Ardhito atas sambutannya, atas pemaparannya. Terima kasih Pak Agung dan Mas Muhammad Ardhito, Mas Dito atas sambutannya. Oke, selanjutnya kita akan berlanjut ke agenda selanjutnya, yaitu ke acara pretest. Oke, jadi sebelum memulai acara pemaparan materi kali ini, kita ada beberapa pretest sebentar bagi para partisipan, bagi para peserta. Oke, udah di-share nih. Monggo silahkan bagi para peserta untuk bisa mengerjakan pretest terlebih dahulu untuk awalan dalam acara guest lecture kali ini. Oke, mungkin kita beri waktu sekitar sampai 13.30 ya, sampai 13.30 lah. Oke, monggo silakan para partisipan bisa mengklik di link kolom chat. Oke, sembari menunggu atau ya menunggu partisipan atau peserta mengerjakan, saya ingin menyapa dulu nih untuk ke speaker kita. Hello, Mr. Kang.
Yes.
Okay.
Can you hear me?
Yes, I'm here. Okay. How are you, Mr. Kang?
I'm good. Thank you very much. Thank you for inviting me.
Okay, thank you. Thank you very much. It's a big honor for us. You can come to join and give us some presentation about material selection. Thank you very much.
You are welcome.
Long time no see, Mr. Kang. How is your day?
Good. I'm looking forward to meet you again in Surabaya.
Oh yes, of course. I want to, but yeah, you know, the condition is COVID.
Yeah.
Cannot give us to traveling. Yes.
Yeah. I have not been traveling for the past since COVID started. I have never flown.
Oh yes, of course.
Yeah.
There is COVID-19 yes. Give us some trouble to traveling. Foreign,
Yeah.
yes.
So he managed to ground me. So I stopped flying ever since COVID.
Yes, of course, of course. Are you ready for the presentation now, Mr. Kang?
Yep. Then I share my screen.
Oh, not yet, not yet. For now there is some pretest for the
Yeah,
participant
okay.
before the presentation begin. Okay, thank you, Mr. Kang.
Good afternoon,
You're
Mr.
welcome.
Kang.
I'm good. I saw one of my old friend Tigor is also joining this session. Just to say hello to Mr. Tigor. And
Hello, Mr. Kang.
Hello, hello, Mr. Kang.
Mr. Agung
Hello, Mr.
Kurniawan,
Kang.
Hello.
Nice to see you again.
our
nice to see you,
adversary.
Tigor.
Hi,
Good day,
Mr. Kang.
Mr. Kang.
Good afternoon.
Hi, Mr. Kang. There are some our teacher, our lecturer, the Mr. Agung Kurniawan. He is our adversary of AMPP SJITS.
Hello. Good afternoon, Mr. Kang.
Good afternoon.
Yeah, nice to meet you.
Good afternoon to you.
Yeah.
Actually, material selection is a topic that I normally won't touch that much. Most of my work is still in Cathodic protection and corrosion. So I occasionally touch on the material selection when it is part of the corrosion course. But this actually is the first time that I have a whole lecture on material selection. So it actually gave me the chance to put more of material selection together. And yeah.
I think it should
I
be
have
fine.
here,
You have more experience in corrosion, and I think it's just range some your experience. And yeah, I think you will give us a very nice lecture for this corrosion, like material selection, or you can combine with Cathodic protection or something like that. Should be nice.
yeah. Good and bad about corrosion and in the corrosion lines, because there are always new things to learn, new experience to discover, and new problems that to be solved and cannot be solved as well.
Yeah.
Oke, masih ada waktu 3 menit. Untuk para peserta, sekali lagi kami ingatkan untuk mengerjakan beberapa soal summary test yang sudah tertera atau dikirimkan oleh para panitia di kolom chat Zoom. Sebelum kita berlanjut ke acara agenda utamanya, yaitu pemaparan materi dari Mr. Kang Kim Ang mengenai material selection in corrosion engineering.
Are you living in Malaysia, Mr. Kang? Are you living in Malaysia or from Malaysia?
Sorry.
Are you from Malaysia or?
Yes, I'm from Malaysia. I'm now at home.
Oh, okay. Yeah.
But I travel quite frequently to Indonesia.
Oh,
The last trip I was in Indonesia was exactly at Surabaya.
oh, yeah.
I was in Surabaya. We have a project together with Mas Iqbal and the team through Sendang Berlian. I saw Pak Agus Sutrino is also in. That was a project that we did together in Python Power Station.
Yeah. I know Python.
Yeah. Indonesia is neighbor that I've been there since 1991. I started in the earlier days was in Belawan, Medan, also for PLN, for the district power station. Then Balikpapan, Senipa, also up to Samarinda.
Oh, yeah.
Yeah. And over the other side, we did some pipeline inspection back in 2008, 2009, in 2010, 11, in Duri and Dumai, where I was together with Pakur.
Okay. So lots of experience. Okay, please let me know if you will be in Indonesia, in Surabaya especially. Yeah, so we can discuss, or you can visit to our university, ITS, and yeah, we can discuss more detail. Yeah, and yeah, because now we have already offline. So all of students go to university to study, and can arrange event offline. It's possible for now.
Okay, so look forward that maybe the coming trip I will visit your university.
Yeah.
Okay.
Surabaya is a very nice city, actually.
Okay, sorry, Mr. Kang and Bapak Mr. Agung, saya potong sebentar. Mungkin ini waktunya sudah cukup untuk pengerjaan pretest kali ini. Mohon maaf sebelumnya. Jadi kita akan lanjut ke pemaparan materi dari Mr. Kang Kim Ang. Okay. Hello, Mr. Kang. Okay, do you ready for presentation now? Yes.
Yes, please allow the sharing of my screen.
Oh yes, of course. Oke, para panitia minta tolong untuk men-share screen materi dari Mr. Kang. Oke. Okay. Do you see the screen, Mr. Kang?
So can everyone see the screen?
Okay.
I'm sharing my screen.
Oh, you want to share yourself the screen?
Yes.
Okay.
Yeah. Because I have the animation done. Polish up. Yep.
Sorry.
So could you see my screen now?
Yes, sure.
Okay.
Okay.
So let's proceed. So first of all, selamat siang kepada semua, and izinkan saya menyampaikan lecture ini dalam bahasa Inggris ya. So good afternoon, everyone, and happy Sunday. Thank you very much to the committee who invited me to present in today's lecture. As I mentioned just now, well, while we were chatting, material selection actually is a very, very wide area to cover within a lecture. And more than frequent, material selection should not be considered alone. We should consider other corrosion protection methods at the same time. However, to concise the material selection itself, what we need to do is to look at some of the important points when we were considering selecting materials. So what I cover here in order to narrow down the area a little bit is from the corrosion protection perspective, the material selection, because there are various types of the material selection that related to deciding what material to be used. Now, in addition to it, I will only focus more to the metal selection. Certainly, there are material selection that we go into non-metallic selection as well. So in order to reduce the area of coverage in today's lecture, my lecture that I cover here are more concise to the metal selection. So what you see in my slides later on, there will be quite a lot of picture or diagrams which are not really from me. I was just thinking of how to pull up the flow of the lecture. Then I browsed through the internet to download some of this diagram or photos in order to explain what I'm trying to deliver here. So please bear with me that you will see some of the photos or the diagram which appear to be familiar with, for you on the internet, which really I just picked it up from the internet and it's not really my collection. Yeah. So without any further, let's proceed with the lecture. Now, what I normally think of from the corrosion protection perspective, the general concept when we think about and talk about material selection, it is this thing first, because we commonly make a mistake by thinking the other way around. So the very general important concept when it comes to the perspective of corrosion protection related to material selection is that a more expensive material is not necessarily a good material selection. So do not have the idea that we commonly say, okay, the cheap one is also always no good. However, when it comes to the perspective of corrosion protection, a more expensive material may not necessarily guarantee us is a good material selection, although most of the time it is. But when it comes to corrosion, we have to consider more other factors together, not just because the material is more expensive. Now, I would like to start this lecture with two stories first. The real stories that I came across through the 20, 30 years, which is with the hope that we can have the idea that when we want to choose a material, a price itself will not really guarantee us that we have a good selection. Yeah? So one of the common things that we normally do, I mean, as a layman at home in normal life, we started by using steel, carbon steel. So whenever we have the problem with carbon steel, most of the time what we think of is to replace the carbon steel with stainless steel. So most of the laymen will think that way. And it's not really wrong. If we go back to our home, go to the kitchen, the dapur, we look at whatever that we use from the carbon steel or mild steel. When we have corrosion problem in the kitchen, we replace it with the stainless steel. So it looks to be a good choice, a stainless steel which is 3 times easily but more expensive than carbon steel, and use the teaching, we see that how stainless steel perform in replace of the carbon steel. So from that point, it gives us a very common understanding or perception that, yes, when we have problem with carbon steel, we go with stainless steel. Now, back to this one, the concept is a more expensive material is not necessarily a good material selection. Let's allow me to recall a real case story back about more than 25 years ago minimum. I was working for a CP company, and a CP company made those zinc anodes. Zinc anodes are used for Cathodic protection. A lot of this application is on ship hull. So the company has a foundry producing zinc anode, and when producing zinc anode, we have all this furnace and the crucible. Yeah, we have furnace and crucible. Although we call the anode as zinc anode, but it has the activating agent in the anodes. So the anodes, although we call it zinc anode, it's not 100% pure zinc. It has the alloying element that we have to add in to activate a zinc, so that the zinc will act as the anode to sacrifice to protect the structure. So the common ingredient for zinc anodes is generally cadmium. So when we are melting the main part of the zinc ingot with cadmium, so we need to do stirring. So we need to stir before we can. We need to stir before we can do this casting on the mold and make into all of this shape. Into this shape here that we can see here. Yep. So to stir this, a metal rod will be used. So just like making the kue raya. So we mix the anodes with the alloying element. So using this rod, stirrer rod, to stir the molten of the anodes before we can cast into this. So what happened during that time? The production manager was quite upset because the rod that used to stir this molten originally was just a steel rod coated with some ceramic coatings, and then use it to stir on. He got upset, the production manager got upset, because this rod cannot last very long. Almost about 10 times around that, he has to replace it. He saw it as the corrosion problem. So as a common layman term, just a layman, when we have problem with carbon steel, so the next thing we always think of is stainless steel. So he went ahead to find a stainless steel rod to replace the carbon steel rod. So when he used the carbon steel rod, the rod lasts about 10 times of stirring. However, when he changed to stainless steel rod, a stainless steel rod just got missing with one first melt inside there, missing. So he just could not understand the reason why, because in a normal understanding, when we have problem with very cheap, very easily available carbon steel, and we replace with stainless steel, it should be better. But for that one, we have zinc molten inside the crucible, and he used stainless steel. So this is a typical example that where some materials are very weak and very prone to certain attack. So one of the common weakness of stainless steel is subject to the liquid metal embrittlement, or we call it LME, and sometimes it is also called as liquid metal cracking. Yep. So this liquid metal cracking, when we have a liquid of zinc come in contact with stainless steel will just give me like the microstructure diagram showing the bottom here, and it easily cause a crack. So this is one of the example that the mistake that we could easily make when we use a more expensive stainless steel to replace a carbon steel, but we ended up have more disaster. So this is one of the general concepts that we always have to tell ourselves from the corrosion protection perspective of it. Comes to material selection, do not fall into the trap that a more expensive material is always a better material. No. So this is one example. Yep. So let me go to another second story where it happens. That is also sorry to tell the story about 20 over years ago. So the real case happened when one fine day I received a call. It was quite morning. I received a call from a friend where we were together in one of the cross-country pipeline projects. We were together in the same project. Then I left the company. He left the company after the project completed. I left before the project completed. Then he went for other company. And one fine morning, he called me. His name is Mr. Chong. So he called me. He said he has something that he could not understand. So I asked him what happened. And he said, look, he was involving in a new project that building a petrochemical plant, an MTBE plant, actually, petrochemical plant. And his project has the storage of the stainless steel piping storage at the open yard, the outdoor open yard like this, not covered, the stainless steel not covered, because stainless steel, in our general understanding, is not going to rust, yeah? Especially just under the normal rainwater in our temperature in Indonesia or in Malaysia, we are almost no difference in the temperature and weather. So the stainless steel has no sign of corrosion at all. Yeah. So then come to one fine day, they wanted to install the stainless steel. So after the storage, they want to install the stainless steel. So before the welding work on, and there comes the instruction from the project manager. He said an Italian. So an Italian project manager instructed them, before they do the welding, wash the stainless steel with acid first, then wash the acid off. Now, this Mr. Chong was puzzled. What he told me is that, look, the stainless steel has no problem under the outdoor environment, and actually, those stainless steel piping had no sign of corrosion at all. So what is the problem to just take it and weld it? So we just could not understand. But the Italian project manager said, wash it with the light acid and then wash the acid off. It is quite massive work for them to remove piping off from the storage deck like this. So he could not understand the reason why they need to do that. However, they didn't get the clear explanation from the Italian project manager. Then when he called me, he said, since I am in the corrosion line, so he asked me, what is the explanation? What is the logic behind? Why do they need to wash this stainless steel when there's nothing wrong at all for this stainless steel? So when I asked him the question, I started to ask him because the stainless steel are stored at the open outdoor. I asked whether the project has painting work or not. His answer is yes. There's painting work around at that area. Then I asked him, are you aware any of those painting systems typically has a coating system started with zinc-rich primer? Now, zinc-rich primer, if you go to get to know a little bit on the protective coating, in the industry, when we call it as protective coating, it is referring to a corrosion protection coating. Because otherwise, when we think of painting, we just do decoration. So those are more of decorative coatings. But when it comes to protective coatings, it is mainly for corrosion protection. So one of the most common protective coatings contains of zinc-rich primer. So when I asked him, do you know that is there any zinc primer could possibly apply inside? And his answer was not sure. So meaning that it was possible. So I told him then, if that's the case, you have to follow the instruction from the Italian project manager. The logic behind here is that the stainless steel has no problem. Yeah, the painting itself has no problem. The zinc-rich primer itself has no problem as well. The problem will come later on. Let's look at this. Yeah. Now, zinc has relatively a very low melting point. Zinc melted within about 420 degrees C. Okay, imagine, yeah, we have zinc melted around 420 degrees C. Now, when I want to weld the stainless steel, the welding temperature and the melting temperature, possibly for stainless steel, just a normal grade only, because stainless steel have long range of stainless steel grade, really. But in general, we will see that the melting temperature of the stainless steel will drop within about 1,400 to 1,530, 550 degrees C. To compare this, stainless steel will melt at 1,400, 1,500 degrees C. Zinc melted at 450 degrees C. Imagine if this zinc dust here, zinc dust in the zinc-rich primer, during the spraying outdoor, and the dust flew over and deposited on the stainless steel. The deposition of the zinc dust here on the stainless steel probably will not cause any problem yet. The problem is waiting. Imagine if we started to weld the stainless steel with the dust on the stainless steel. What happened to the dust of zinc? It means that the dust of zinc will be lightly melted before come to the welding temperature. Probably within the preheat temperature is already worse enough for a zinc to melt before it comes to the melting temperature of stainless steel. So once that welding of the stainless steel is on, that means it is time that this zinc dust will turn to become liquid zinc. And that is where this problem will be coming, like what we watched in the movie of Terminator 2. Yeah? If we recall, the movie of Terminator 2 that symbolized a very typical liquid metal. The liquid metal, metal in a liquid form at the atmospheric temperature, so far as I know, is only mercury. Yeah, but so that is another real case story that when we want to select materials, we have to be aware of other than the material itself. We got to know what process is coming around. So the Italian project manager has given a very good instruction before the problem happened. So what we can see in this case, we do not see the problem happen. It's going to happen when zinc dust is as zinc dust, stainless steel pipe is as stainless steel pipe. So the problem is only coming when the welding has been taking place on the stainless steel piping where the zinc dust could be deposited on it. So these two stories has just for us to begin with the concept that what the factors and consideration that we have to look at when it comes to material selection. Now, in a very common views when we want to consider material selection. So these are the triangles on the material selection that we'll consider. When we go to the real industry, the bosses will be most particular about the cost. So we got to think of the cost, yeah, and we also have to think of how can we get these materials, yeah, how can we get these materials. For example, like Indonesia now, you have a great advantage because of your nickel mineral reserve, where I was with Tigor on one of the projects in Sulawesi. We went to we had a project in the nickel plant in Sulawesi. So we have to think of the availability of the material as well. And last is the practical part of it. We have to understand the properties. We have to understand the practicality of using these materials, and also have to make sure that this material has to be safe to be used in that environment. Safe in the sense that it will not fail as unexpectedly. Safe also in the sense that it will not cause the environmental issues. Yeah, because now this has become more and more a key concern in a lot of engineering consideration. Now, let's look at the cost. Yeah, if we look at the cost of material itself, if we do not consider the cost, we just consider corrosion protection. Looking at just corrosion protection itself, let's take some example here. Now, most of the time, I and Pak Agus as well, and Iqbal and Tigor also, we are dealing a lot with pipeline. So this is one of the old map of the pipeline around within these few countries in Southeast Asia. We knew that there are two pipelines going into Singapore from Sumatra, and also from your Natuna go to Singapore, and also the in Peninsular Malaysia we have this cross-country natural gas pipeline, and over in Borneo we have the pipeline crossing 500 over kilometers. Not to mention about what you have over the Kalimantan and cross over to the island of the Java. So I was involved in one of the I remember it's 24 inches natural gas trunks Sumatra as well. So if we do not consider cost of it, just consider the corrosion protection. So if we think of, can we use gold, because we want to have corrosion protection, can we use gold to construct this type of the pipeline, the cross-country pipeline? Certainly back in your mind, this is no. Yeah. Otherwise, anyone who go to cut a piece of this pipe will become millionaire without working hard already. So we say this is no. And for other construction, as engineers, we know that we always have the challenge to make something happen within the cost, within the money that we have or budget that we have. So imagine that these are the construction that we are dealing with. And for the oil and gas exploration, they are onshore. We see a lot of this driving from Pekanbaru to Duri. Not to mention that we both Indonesia and Malaysia, we have a lot of this offshore platform, and now those mega ports. If you go to your Batam Island, you have a big port over there. So imagine that, how could we afford to use gold just because of wanted to have corrosion resistant? So it is no. So we always have to consider the cost that we need to incur to select these materials. Yeah. Now, if that is the answer is not, so what else should we consider? Yeah, when we want to do the material selection. So for the cost factors consideration, when think of cost, so these are some of the things that they think of when become a cost. So first of all, of course, is the raw materials cost. Yeah, the raw material cost, the processing cost, whether we have raw material, but the processing cost could be very, very high, or the raw material probably do not need a high processing cost, but it could end up with very high raw material cost itself. Not to forget, of course, the production cost of it and the production requirement. The production, whether it involves that welding, what sort of welding that we need, what sort of the fabrication we need, and the kind of manpower skill. Yeah, the welding is a huge process to be involved, and various set up the welding. We have to make sure that this could be set up for the fabrication and the production of the metal. So we cannot simply say, I want that, but the whole production cost could be very, very high that come to impact in the project cost. And not to forget is the life cycle cost, which means that we do not want to select something that are cheaper at this moment, but it does not last long enough or physically that meet the budget requirement. Yeah, so we have to think of that prospect as well, because it's something that we need to last probably not 50 years, but we want to last 10 years. We do not want to install some of the structure which lasts only half a year. Yeah, so the life cycle cost, although the initial cost could be cheaper, but because of it does not last long enough and need a lot of intervals replacement, it could end up with very high life cycle costs as well. So we also have to be sensitive enough to know what kind of budget do we have and how much of the budget that we have in order to select a certain materials. So as I said before, when we actually go to the real industry, real world, the bosses will only give you 1,000 rupiah less and never give you 1,000 rupiah more in whatever way the budget be given. So that is the real life. So all of us being engineers, we are always been told that is the budget that you have and make things happen. Yeah. So that's the challenge of the engineers. So when it comes to availability, yeah. First of all, we have a project to meet. Yeah. We cannot select materials that where a project needs to be completed in 2 years, but this material can only ready in 3 years' time. So we have to consider whether the material is ex stock or ready stock, and can the material be delivered or be produced within the project schedule. Yeah, so we need to finish a project within time. Yeah, that is the real world. Yeah, so then at times we need to tailor-make certain parts to the size or the dimension or the shape of what we wanted to use. Yeah, how possible it can be formed in terms of against the size, the shape, the texture, the profile. If you look at this diagram here, the large, huge bridge. Recently, I just watched one of the YouTube of the bridge construction in China. So one piece of the block they install on a bridge across Macau to Hong Kong. The weight of the metal that for one piece of the bridge to be installed on only one piece of the whole long bridge is half of the weight of the Eiffel Tower in Paris. So how possible that could be formed, that could be fabricated or constructed? Yeah, and some of the parts could be that tiny. Yeah, And sometimes we also know we only want one piece. So the factory will tell us, no, we are not going to produce one piece for you, because factory is the factory. Yeah. So we have to think of any special tooling that required. And now, especially with the 3D printers come about, a lot of a small quantity order could be possibly tailor-made too. So we have to think of whether this can be produced by the factory. If it's not, can this be produced using 3D printers? So these are some of the things that we have to consider: the availability of the product, the parts that we wanted to select of the material to make of it. Now, the other one, which is the requirement of the skilled manpower at the construction site. One good example is the duplex stainless steel welder. What I remember when I spoke with some of the friends, there was an incident before in the whole Southeast Asia. We could not find a qualified welder who could weld the stainless steel at site. So imagine if we are going to select a materials, which is good materials, but because make sure not only the availability of the material itself, but not to forget the availability of the skilled manpower. So if we want to buy a specified duplex stainless steel, back in our mind, in this case, we have to also consider how that construction is going to be. If that needs a welder, we have to think of, can we get a welder to come in to do this welding or not? Worse still is if this is the underwater welding. So the underwater welding will have a lot more other factors to be considered at the same time, other than the material itself. The setup of underwater, the depth of the where the work is going to be carried out, how to protect the divers due to the pressure. So we need the decompression chamber to protect the welder from getting the pressure problem in the blood. I can't remember that term already. So these are some of the things that when we want to consider the selecting of materials, it is not that straightforward that the material is suitable. We have to look at other factors, especially in the real world. We have to make things happen. It's just not a piece of metal itself. Yeah. So that is the availability of it. So now, a more wider perspective to look at the material selection is to look at the properties, the practicality, and the safety of these materials. So I have more slides here. Now, to start with, there are various properties when we select a material, starting by looking into the mechanical properties of the materials. So from the metals itself, we have to consider the type of the strength, the type of toughness that we need for the structure, which are more prone to the impact and dynamic load, like impact. So various testing could be done first. This kind of the failures, yeah, the dynamic load on the bridges, and the toughness on the gears, yeah, on the pole, the toughness that we need, yeah, not to have something that stand up and will buckle after a short while, and whether or not, like a pipeline, could take first of all the operating pressure, what kind of the pressure that we are going to operate this pipe, and what kind of terrain also that we wanted to operate this pipe, or where this pipe is going to construct on. So for example, one of the very tough decision to make is when we want to construct a cross-country pipeline like this, which need to be a very high pressure, but crossing a very undulating terrain, meaning that a very mountainous terrain. So if we want to have a pipe which can sustain very high operating pressure, normally we go with the higher X degree, higher carbon content, so that it can take the internal pressure from the hook stress. Hook stress means that you just imagine that a pipeline which is round, when we have opening pressure, it's just like blowing a balloon. So we call it hook stresses. So we can have a high carbon steel to hold the pressure of the hook stress. But if this pipeline is going to be at the undulating terrain, a very mountainous area at the Bukit Bukau for the pipe to cross, then the pipe which is too stiff that to take this terrain might have the longitudinal problem, because when we construct the pipeline, it is not all the walls straight. We could have bend, we could have sagging, and various sort of other effect, not to mention about the earthquake. Yeah. So these are some of the properties when we want to select a material. So imagine that example that I mentioned about the high pressure pipeline crossing a very undulating terrain. So how to select this material so that we can serve the purpose while we want to transport the product inside the pipe with very high pressure. Then the outside we are experiencing such an the environment of undulating. So other than that, another type of the mechanical properties of metal typically is the hardness of it. So hardness, how strong that the material will resist the deformation, like bending, scratching, abrasion, cutting, so on and so forth. So as the materials student, that some of you or for mechanical division as well, one of the example of the hardness requirement is actually on our brake disc on the car. So we need a toughness, but because during the brake is always the abrasion. So how to have a materials that we can have the toughness that it will not break off, at the same time when the brake pad abrades on it, it will not just wear off easily. So these are some of the mechanical properties that we have to consider. So the kind of wearing due to the abrasion, the impact, and also of course the fretting wear, especially when you are having something that been vibrating all the while, like on the shelf, for example. The surface fatigue corrosion is typically on the cyclic load that been repeating round and round. So erosion wear, when you have the construction that envelop your structure has some sharp angle, so certainly that we have to consider the kind of hardness to resist the erosion effect. So that is from the mechanical prospect. And not to forget, the other one is to look at from the physical properties of it, of the material. So physical properties could cover something like the thermal coefficient of the material that we use, or the thermal conductivity. So for example, if we are selecting materials to be used on the heat exchanger, so we want it to be corrosion resistant, and which has the good heat conduction as well. So we don't want to use the materials which is strong to resist corrosion, but it cannot effectively transmit the heat. Then the thermal expansion. So the photos at the bottom here, we have to be aware of the material that we choose will not end up with this due to the thermal expansion. If we go to some of the petrochemical plants, when you have pipings around, sometimes you will see the expansion. We call it expansion release, or the stress release band. Yeah, so those are something to do with the thermal expansion, and of course the electrical conductivity for certain materials that we want to use, that we need them to have a good electrical conductivity, such like superconductors. Recently, I've also watched another video that normally when we want to have a natural superconductor, we got to have a super low temperature. But then they are now being developed again in China for the future train using a superconductor, whereby they call it high temperature superconductor. Of course, the high temperature that mentioned is only relatively high temperature. It is still a low temperature, but this new material that been used is a material that can be still act as a superconductor, even with relatively higher temperature than the normal superconductors. So that is the electrical conductivity. And sometimes we have to select a material that we really have to think of the density of the material. So one example, of course, aircraft is a typical typical industry that the density of the material is the main factor to be considered, because we really have to allow the aircraft to fly without the unwanted load on it. So on the aircraft, the two most common metals on the aircraft, because of the density that we need to consider, first of all is the aluminum. You can see that the light blue area at this aircraft that I got from the internet, that mainly consists of metal, and most of these parts of metals are really made of the aluminum. And the aluminum that used on the aircraft are commonly been anodized. So it's just not the common aluminum that we use on our door frame or the window frame. So those are the anodized aluminum. If you do some research about the anodizing, so these are some of the process that we can thickening the skin. I call it skin, but it's actually the oxide layer, to oxidize the outer layer of aluminum, which can then provide, first of all, is in terms of the corrosion protection of the aluminum. Secondly, it increased the strength of the aluminum a lot with this anodized layer. And the other one is because of the deflection of light, it can give some natural coloring as well to the anodized aluminum. So this is one of the most common material that used on the aircraft. The second most common material used on the aircraft is titanium. We know that titanium has a properties of incredible strength, and the density is almost like aluminum, lightweight. And the other advantage of titanium is certainly because of heat resistance. So for the aircraft engine, so that will be one of the good material selection for it. And not to forget about that, the titanium is also having a very good corrosion resistance. And titanium has become the quite a lot as a base material for the corrosion protection metals when we have the coated surface on the titanium. So this is where we look at the materials selection on the aviation industry. So now, again, back to this one, a more expensive material is always a better materials. We'll put a cross on it. So when we want to consider the properties of a material from the corrosion resistant perspective of it, so we do not just consider a cheaper materials. So the materials that we select for the corrosion resistant can be a relatively much cheaper materials. It can be more compatible with the environment as well. So it could be sufficient resistance to corrosion, yeah, within that service life. And more importantly, yeah, these cheaper, relatively cheaper materials can easily come along with the preventive maintenance during the service life of the materials. So the preventive maintenance includes some of this, like we can consider a cheaper material come along with the corrosion protection methods, like carbon steel come with proper protective coatings, for example. Yeah, so we can also implement the routine inspection when we use relatively cheaper materials to make sure that before the failures comes to a terminal state, that we cannot salvage it. Before it comes to that stage, with the inspection, we will know upfront and do any repair or mitigation exercise. Then, in between of that, with the cheaper material, we can also implement the intervals maintenance and repair for the materials. So this is to give us the alternative than just to select a more expensive materials in the material selection. Yeah, so from the corrosion resistant perspective of it. Now, when we want to look at the environment consideration, so these are some of the things that in the real life, when we expose a certain structure to the environment, so these are some of the external factors which we need to consider in using those materials, starting by the chemical composition of the material itself with respect to the environment that it's dealing with, or the chemical composition of the environment. Just about 2 hours before the meeting just now, I received a call from a project manager who is having a problem on a cooling condensers where the coatings has give way and they open out the condensers. He has a lot of the corrosion appear that we was talking about. He mentioned they have the corrosion inhibitors dosage onto the cooling water. So this is what the chemical composition that might relate to, and what are the physical state or kind of solid that might come in between. So kind of the liquid gases as well. Then other external factor, it can be the load, yeah, the dynamic load, for example, vibration, yeah, fatigue, various of those external factors, or even sagging, yeah, sagging of the pipe. So like operation, like the offshore subsea pipeline. So sagging is always one of the factors being taken into consideration for the pipeline. So other than that, the organic matters and the bacteria. So same like the COVID giving problem to us in the corrosion industry in recent years, bacteria has been recognized to be one of the common culprit to the corrosion, especially when dealing with the sulfate reducing bacteria and the acid producing bacteria, the SRB and APB. Yep. Then the temperature, the pH, conductivity of the electrolyte come in contact. Conductivity can be, we can see the difference. For example, the normal potable water as compared to seawater and the river water. Even river water, we got different type of river water, the upstream, downstream, and the river mouth. Yep. And also the dissolved gases, especially like the gases like oxygen in some of the products, and certainly gases like H2S, the hydrogen sulfate, is one of the most scary culprit in the corrosion industry. Yeah, because that will really cause a very scary corrosion, especially when dealing with stress corrosion cracking. Yeah, then we have to consider whether the material can sustain that the hydrogen sulfate or not. Now, one of the example I would like to quote now is another example again that we normally will think of about galvanizing. So I received call many years back. A university lecturer has been consulted to whether or not is a galvanized steel suitable to be used for the underground application. Yeah. So the question now is that, is a galvanized steel a more corrosive resistant than steel, which come with a component of the corrosion prevention? So now, to look at the example here, so we're looking at the material selection. Now, if we take example as selecting galvanized steel, so we have to first understand the properties and the advantages of this galvanized steel and the disadvantages of it first. Now, it is well understood the advantages of the galvanized steel. For example, it is relatively lower cost, because it could be produced from the factory. When it produced in the factory, it can be mass production, and there is the production cost be relatively low. Yeah, and it has claimed to be less maintenance, lowest long-term cost when it performed well. It has been classified as long life. Certainly, we have seen some galvanized steel long life. It is reliable. It is tough coating because it's a metallic coating as compared to those polymeric or the organic coatings. So it's automatic protection due to a little bit of the cathodic protection properties of it at the damaged area. It can give a sort of the complete protection and is easily inspectable. Like even with a visual inspection, we could inspect the galvanized steel. So when we look at this, it certainly gives us a good idea that galvanized steel is a good choice. And now some of the expensive car, I don't know whether it's right or not, one of the German-made car, where half of the car is actually galvanized, ready galvanized on the frame like this. So that shows the advantages of the galvanized steel. But the thing is, all has been described here is referring to the corrosion resistant and the advantages of galvanized steel in the atmospheric environment. I don't know how to remove this. Okay. In the atmospheric environment. Atmospheric means that to the open air. The open air, and it is not being covered. Yep. So if we look at that galvanized, before we go further to see the advantages of the galvanizing, now the disadvantages may come in order to understand the disadvantages of galvanizing. If we want to select it as a material, we need to understand these properties of the corrosion resistance. Where does it come from for the galvanized steel? Why galvanized steel is claimed to be corrosion resistant? We inverted just now in the previous slide that it is good in the atmospheric environment. Now, in the atmospheric environment, when a galvanized steel, where the zinc layer is exposed to the environment. Now, in the common environment where oxygen is easily available, and the flowing air, due to flowing air, when it gets moisture due to rain, due to dew, condensate on the surface of the zinc layer, because internal it should be steel. That's what we call galvanized steel. So zinc is only at this outer layer facing the external. So when the water, the wetness comes in together with the oxygen, then it will start to have the hydroxyl, zinc hydroxyl, here. So zinc hydroxyl is not a good product. That is, sometimes we call it as the a kind of a white rust. So if we don't expose it to the air enough, typically when we have those galvanized zinc sheet come along and stack to each other and water get in, after some time when we open up, we'll see white spots on the galvanized steel. So that those are the typical white rust that happen on the galvanized steel. Now, the most advantage of a galvanized steel comes from the formation of what we call here at the most bottom, which is zinc carbonate. Now, zinc carbonates can form and stay firmly with the condition when we have the flowing air consists of oxygen as well as carbon dioxide. Then only we have this layer we call patina of zinc that will protect the base steel from corrosion. And the zinc carbonate here has a very strong mechanical properties in terms of the hardness, in terms of wearability, and certainly in terms of the corrosion protection. But we must understand that this can only happen in the open environment, atmospheric environment, when we have free flowing of the air. However, if zinc is used for different purpose at different environment, the corrosion resistance of zinc is very of the galvanized steel is very much depending on the condition of free flowing air which will form the zinc carbonate. So if that condition is not given, so it is a relatively much poorer corrosion resistant when this is used in wet soil and water or seawater. So when we want to use a steel in wet soil and water, submerged in water, galvanized steel is not a good choice. So my answer to my friend who lectured in the university is that should not consider, should not expect a galvanized steel to perform well when it is buried underground or submerged in water. Yeah. So this is, again, the environment will determine the performance of the material itself, not just the materials. So it works very well in the atmospheric environment, but it goes very, very poor when it comes to underground, buried underground or submerged in water. So when it comes to wet soil and submerged in water or seawater, a better alternative to galvanized steel is using just a steel, come with coating, allow a reasonable percentage of coating defect or holidays, plus with Cathodic protection. This will give a much better corrosion resistant performance as compared to hoping from the galvanized steel. So again, let's look at when we look at the material selection. So some of other considerations that we have to really take into account, not just the material itself. So this is not uncommon that we always come across a water pipe, above ground water pipe that we use to tap for the tap water. Whenever we remove the tap water pipe, what we encounter, the external of the tap water pipe, where the galvanizing layer could still be intact and could still be in very good condition. However, the internal, which was galvanized at the same time, can see with this type of the thick rust develop inside the pipe. So again, this is the example that it is a good corrosion resistance for the external, where it is exposed to the common atmospheric environment, but it's very, very poor and for the inside of this galvanized pipe because it is in contact permanently with water. Yeah. So now, if we travel along the main road or highway, we might come across of this guardrail, commonly a galvanized guardrail, and sometimes we see an example like this. Some part of the guardrail are still in good, some part of the guardrails are already rusted badly. The reason being is because it is a common problem that for hot dip galvanized process, the thickness of the zinc layer is often very hard to control. Yeah, it subjects to a lot of factors, typically like the temperatures, the content, and so on and so forth of the base steel itself. So it could end up one piece of the guardrail which lasts well, stand well, because of the thickness was meeting the requirement. And next to it, we have something like this already. And not to forget, typically when in the hot dip galvanizing process, because it is something to do with molten. So something to do with molten is just liquid. Liquid when it comes to sharp edges. Yeah. So the solidification of the molten may not be thick enough at the edges. That's why often we see the sharp edges of the galvanizing sheet often have the corrosion started first. And also as the urbanization, when more of emission of carbon dioxide, which will cause the environment to be more and more acidic now when it comes to rain. So we know that zinc is very poor and very prone to the corrosion caused by the acidity. So when we have the urbanization, zinc may not last as what we expected. So this is another disadvantage of the galvanized steel. And this is another example that the splash zone and tidal zone with the submerged and the buried in situation like this, the river, for example, or the seaside, we often see the steel come to this state. So again, I had one experience with a Australian galvanized sheet pile manufacturer who has supplied and installed the sheet pile for a river declaration project. So the ended up the sheet pile made of the galvanized sheet has corroded within 2 over years, where they expect easily to last for 20 years. Yeah, so we really have to consider the corrosive environment. So one of the examples that I would like to share with you and also bring you to visit the historical city of Malaysia, that is Melaka. So let's look at, this is how beautiful the river activities, the water activities around Melaka River. What I want to bring up here with such a beautiful scenery, we look at down here at the wall side of this river, because of they wanted to have the water activity that the boat can be traveling up and down along this river. Then they have the barrage gate up at the river mouth so that the depth of the water will also maintain to allow the boat to travel along this Melaka River. And in order to do that, they have to dredge the river and also to wall the river with all of this ship pile. So this ship pile was originally made of galvanized ship pile. And in very, very short period, the corrosion has started to show. So this was one of the typical example of wrong material selection for this kind of application. So as we now understand that galvanized steel is very good for atmospheric corrosion resistant, but when it comes to submerged or buried, or even the intermittent wetness of the surface, not like just rainwater, so then galvanized steel will be a very, very poor selection to go with. So this was what happened in Malacca River. The corrosion on the original galvanized steel ship hull within a very short period, about 2 to 3 years, and it was those were then recovered and repainted using paint already. So all the galvanized were just waste for this type of application. So that is another example to share with all of you. Now, I would like to bring to you all one of the last example here is the usage of what we call as clad steel. Clad steel are often the CRA clad steel metal. So what is clad steel here? So this diagram is showing that it's typically the combination of more than one type of the metal to be clad together with a few type of processes. Some can use just the explosion. There are various type of the process to get this clad steel. So why do we need clad steel? So looking at this, clad steel could be one layer of the stainless steel and one layer of the aluminum, like shown in the bottom diagram here. Yeah, we have stainless steel layer, we have aluminum layer. More frequent, we have stainless steel layer and then normal carbon steel layer. It can be made in a sheet or block like this, and more commonly also it can be made in terms of the pipe like this. So an industrial example of using the clad steel. Now let's look at these two diagrams here, a typical subsea offshore pipelines. Yeah, subsea offshore pipelines in the oil and gas production. We will have the products inside the pipe, and we have the seawater outside of the pipe. Now, some of you probably has know already that although stainless steel seems to be one of the very good materials against most of the corrosion, but stainless steel is typically very, very sensitive and very prone to chloride attack. Very prone to chloride attack. And when a pipe is going to be installed in the under the sea with the seawater around, and when it is sensitive to chloride, what do we expect from there? So now, in the oil and gas production, we could end up of this situation as problem statement. Inside the pipe, we could end up needed to carry the sour gas, acidic gas. Yeah? There are jargons that we use in oil and gas. We call those products as sweet products and sour products. Yeah? In general, the sour products are referring to a more acidic product that we are dealing with, especially when we started to have a higher content of the hydrogen sulfate content in the product. We start to have the sour product. And now, if we want to construct an oil and gas pipeline, which is going to carry a product which is acidic. Now, if we have acidic environment, the normal carbon steel cannot sustain the acidic environment. So if you want to carry a product, if use the carbon steel to carry the sour product, the steel pipe will not last. So we have one problem. So if we have that problem, the next thing we think of, can I go with stainless steel, which is good, resistant against the acidic environment? So then, if we consider the stainless steel as a pipe to carry the sour products under the sea, we are having the seawater containing chloride come against the stainless steel. So we are hand-tied. When we want to go to have the corrosion resistance against the sour products, we wanted to use stainless steel. But outside, we are having seawater. So this is the problem statement that we are facing. The question then, do we go with stainless steel or we go with carbon steel? If we go with stainless steel, it's good to go against the internal corrosion, but it is very sensitive to the external corrosion because of seawater. So on the other hand, if we want to handle the seawater outside using carbon steel, we will have problem of the sour products inside the pipe. So this is one of the situations that we end up that the material selection could be very, very challenging. So the solution in the industry, one of the solutions that been used in the industry is to have the corrosion resistant alloy or CRA like stainless steel or different grade of the stainless steel for the internal, and then we allow the carbon steel to be the external and come along with coatings and cathodic protection for external to fight against the corrosion by the seawater. So in this case, we solve the problem that we face over here. So we have the internal with the CRA, which is sustainable against the acidic environment. And then we have the external of carbon steel with coatings and cathodic protection against the external corrosion from the seawater. This is another concept of the material selection that we speak about. So those are some of the example and the factors that I could share with you all in terms of the material selection. But it often comes to another question. So if after we have considered all of the suitable materials for suitable environment, what else do we still have to consider? So I have the example here, from the photos. We have selected good materials from all the consideration earlier we have. But we also then now, what else do we need to look at? We need to also look at how are we going to apply this material and how are we going to fabricate these materials. So these two photos on the left here are the photos from one of our projects when we were engaged to do the failure analysis at site. So they have selected the stainless steel 316 for this piping, but then they have used the carbon steel bolt and nut to go along with the stainless steel flanges here. So that this one is from internet. You can see that the parts under the motor has corroded badly, and this is very common for us when we have the water tap that come along with the steel pipe or galvanized water pipe, that we have this corrosion that occur. So it could be that we end up there is no such an ideal materials to be selected, really. So although we discuss about the material selection here, we talk about what materials are sustaining to what environment or most suitable to certain environment. But bear in mind, there will be situations that we come across that there could be no ideal materials for all. So what we need to consider then. So this is the last slide that I have here. So other than considering suitable material for suitable environment, I think personally it is important when it comes to the corrosion perspective, first of all, is to understand the various type of corrosion. When we speak about various type of the corrosion, is to understand what has caused various type of corrosion. For example, crevice corrosion, galvanic corrosion, fatigue corrosion. So we have to understand what are these corrosion and what causes this type of corrosion happening, and look back into the material that we select to use on this particular project that we are dealing with. What else do we need to be aware of before we really go ahead to use the materials? And then at the same time, to look at the causes of this corrosion. Can that corrosion be mitigated, or can that be avoided from the corrosion? So then, other than that, we also ask question: what other corrosion protection methods that we can use as a better choice? So which means that we do not need to tie our hand to just limit ourselves to selecting materials. We can also look into what other type of the corrosion protection methods that we can apply at the same time. If we have no other choice, when a single selection, it cannot satisfy all the requirements that we have. So we also can ask the question: is that possible to have the interval replacement of parts, a more realistic option? So sometimes, no matter what material that we use, so we might end up that the material will still degraded, corroded, or can that then be replaced in the replacement is a more realistic option? So something like, if to replace this part, it can be easily removed and easily replaced, then possibly to use a less corrosive, corrosion resistant materials, but then replace it from time to time. And is there a shutdown for this plant's operation or this activities operation? Is there a shutdown? Is there a turnaround? So can the replacement be done during that intervals of shutdown or turnaround? Or we can consider cheaper materials. So, and easily available. So not so expensive, not last very long, but it can last within the intervals of shutdown or turnaround. So not to forget, lesson learned is always a very, very valuable asset that we should have. So learn from the lesson, learn from the failures, learn from the success as well. So all the history, the experiences, the lesson learned can be a good guideline for us to select materials. Last but not least, anything at all that we can consider. Not just limit ourselves to the material selection. So with that, I think that all that I prepared for this lecture. So thank you very much, everyone.
Okay, thank you, Mr. Kang, for your great presentation.
So I'll stop sharing my slide then.
Oh yes, okay. This is a great sharing about material selection. I think there are so much knowledge about material selection. Oke, selanjutnya kita akan beranjak ke agenda selanjutnya, yaitu ke sesi Q&A. Silahkan bagi para peserta yang ingin mengajukan pertanyaan, bisa mengajukan pertanyaan dengan menggunakan fitur raise hand dan mengaktifkan mic-nya, lalu menyatakan pertanyaannya langsung ke Mr. Kang. Oke, monggo silakan dari para peserta atau partisipan. Boleh lewat mic atau bisa juga melalui kolom fitur chat. Silakan. Oke. Silahkan teman-teman, mumpung kita lagi kesempatan nih, kalau menurut saya. Lagi ada Mr. Kang, apalagi Mr. Kang ini orang yang sangat berexperience lah menurut saya di bidang korosi tentunya. Jadi sayang banget kalau tidak bisa memanfaatkan kesempatannya. Baik dari para mahasiswa ataupun di public non-member AMPP SCITS. Oke, silakan teman-teman. Unmute. Okay, sorry, Mr. Kang. There is a question from Rizky. I will read the question. Hi, Mr. Kim. Thank you for your presentation. The question is, could you please elaborate more on electrical conductivity consideration in terms of material selection?
Yeah, I would answer this from the actual application. For example, in one of the projects that we have is yeah, for example, we know that if we go to internet, we could see and research around some of the metal properties of different metals. We can see the conductivity of various metals in the range of the common temperature. So for example, that if we look at comparing the conductivity of a normal steel compared to stainless steel. So stainless steel is less conductive as compared to carbon steel. Yeah, so that is the difference about it first. Now, one example of the project that we involved in, we wanted to use a kind of bolt and nut to punch through a clamp on the pole. So we have a pole that we need to clamp it, and then have a cable on the clamp to produce the conductivity to the pole. So we have this clamp come along, and then with clamp on the pole, we have a bolt that has to punch through to this steel pole inside. So then this bolt that we use is meant for conductivity. But when we wanted to consider earlier, because it was meant for offshore platform area. So my engineer first was thinking of, because offshore, we were concerned about the corrosion, because if you really go offshore, you can see that the metals, the corrosion problem is really serious. So when we were considering, wanted to have the corrosion resistant, the first choice is actually using the stainless steel bolt for the continuity. But because we need electrical conductivity, so in that sense, the choices here, because our main choice here is the electrical conductivity. So when we are making the material selection to think of whether we should use the stainless steel bolt and nut or carbon steel bolt and nut. So then our decision is we need the continuity more. So we have to choose the carbon steel bolt and nut and come with the grease around after the bolt contact has been installed. So this is one of the examples that I could see that the situation where we have to consider between the various materials when we need them to be having a good electrical conductivity. So it's just an example. So there are, I think certainly there are various situations that we come around that we need to consider at the same time the corrosion resistance and the electrical conductivity. The same thing comes with those thermal properties as well. Yeah.
Okay, thank you, Mr. Kang, for your explanation. Oke, apakah sudah menjawab dari Rizky? Dari jawabannya Mr. Kang?
Sudah, Mas Iqbal. Terima kasih.
Oke, sama-sama Rizky. Oke, selanjutnya Mr. Kang, next. There is some question from Elvira. I will read the question. Excuse me, Mr. Kang, I want to ask what is different and benefits of method material selection than the others method for corrosion protection?
Oh, if we want to classify, thank you, Elvira, for your question. If we consider classifying the corrosion protection, material selection is can be considered one type of the corrosion protection. But personally, I look at the material selection are more related to the design first, and then it is more of a passive corrosion protection. That means we just get ourselves ready as compared to some other corrosion protection. For example, the common one like coatings. Coatings, in a way, is also very much of as a passive protection, unless those consist of the additives which are more actively go against the corrosion. So there's no really clear difference between material selection and other corrosion protection. It's just that for a total corrosion control, really, for total corrosion control, we often, as an engineer, we often have to consider more than one type of the corrosion protection for us to achieve the corrosion protection within a reasonable cost. Again, as engineer, we must think of how to make things happen within a reasonable cost. So the answer is there's no difference. So it's just one type of the corrosion protection.
Okay, thank you, Mr. Kang, for the explanation. Oke, apakah sudah menjawab ya? Cukup menjawab dari jawaban Mr. Kang?
Yes, I get the point. Thank you, Mr. Kang, for your answer. I really appreciate that. Thank you.
You're welcome.
Okay. Oke. Mungkin dari kita saat ini dalam acara Gestalter ini akan membatasi 3 pertanyaan saja, mohon maaf. Jadi apabila nanti ada pertanyaan selanjutnya bisa dilanjutkan dalam waktu atau melalui email mungkin dengan Mr. Kang nanti. Oke, yang terakhir. Oke, the last question, Mr. Kang. There is some question from Hendy Setiawan. I will read the question. Thank you for your presentation, Mr. Kang. Regarding the galvanized steel, as you mentioned earlier, it is understood that the galvanized material require free O2 and CO2 from the air to form protective layer. However, I found that many firewater pipe, fresh water, using galvanized pipe. Is there any explanation of this case?
Yeah, interesting question, because governance pipe for fresh water is almost that we see daily on top of now those UPVC or HDPE pipes are becoming more popular in place of galvanized materials. I personally feel that the reason that it has been used commonly is because at least from the external corrosion resistance of it, most of this galvanized steel pipe in the above ground are still performing reasonably well with the cost that we pay for, because it is still relatively quite cheap. The other reason is because the understanding of the corrosion resistance from the common community are still not as common yet. That because once we see the galvanized steel perform well when we at the area that we can see, like above ground, at home, next to the wall, and outside next to the building wall, when we see those galvanized pipes from the external part of it, the galvanized layers stay long and stay nice for a long time. It gives the impression that these pipes are reasonably corrosion, good corrosion resistance. But we can see, like just now, one example that the internal of it is really not as hot. And if anyone has actually seen before, when a buried galvanized pipe like this is excavated, we always seen those pipes condition are much worse than the one that above ground or next to the wall at home. So very much it is lack of understanding of the corrosion resistance that galvanized steel are bringing to. I think it is very so lack of those understanding.
Okay, thank you Mr. Kang for the explanation. Oke, apakah sudah menjawab Mas Hendy Setiawan dari jawabannya Mr. Kang?
Ya, udah.
Oke, terima kasih Mas Hendy. Oke, berhubung waktu dalam sesi Q&A ini sudah cukup, mungkin kita akan melanjutkan ke agenda selanjutnya, yaitu kita akan ada penyerahan secara simbolik untuk sertifikat terhadap Mr. Kang. Okay, the next agenda is to handling certificate symbolic with you and with our head of department professionalism, with Mr. Muhammad Ardito Pramudia. Oke, silakan panitia yang bertugas untuk share screen sertifikat. Silakan Mas Ardito, waktu dan tempat saya persilakan.
Thank you, Mr. Iqbal. Yeah, so I'm gonna give you some certificate for our lecture. Mr. Kang, thank you for joining us. So I will lecture.
Thank you very much.
Thank you. This is our certificate, and yeah.
Thank you very much.
Oke, didokumentasi dulu nggak? Saya aba ya untuk dokumentasi. Oke, Mr. Kang, we will take a picture. Take a picture.
Okay.
Count. 1, 2, 3. Okay. Okay. Again. One more. One more. Okay. Take picture again. 1, 2, 3. Oke, thank you, Mr. Kang.
Thank you, everyone.
Oke, thank you, Mr. Kang.
Stay safe. Thank you. Have a nice weekend.
Oke, thank you. Have a nice too. Oke, selanjutnya kita akan sesi dokumentasi bareng bersama dengan peserta. Oh ya, saya mengingatkan sebelum pada live nih, untuk bisa mengisi link feedback dan juga post test pada kali ini. Jangan lupa ya untuk mengisi link post test dan link feedback. Oke. Dan selanjutnya akan ada sesi foto. Ada sesi foto nggak nih? Foto bersama peserta dan partisipan. Monggo untuk panitia yang bertugas bisa men-share.
Ya mungkin buat teman-teman peserta yang belum on cam mungkin dipersilakan buat on cam dulu. Oke, baik, karena sudah tidak ada yang on cam lagi, mungkin aku bisa hitung mundur ya. 3, 2, 1. Next slide. 3, 2, 1. Oke, makasih. Saya kembali lagi ke Mas Iqbal.
Oke.